The Red Sea's northern corridor carries a navigational history that most of the sailors who transit it have never read and do not need to. The charts mark the hazards in the standard notation: shoals, wrecks, depth anomalies, but the charts do not fully capture the particular quality of the water in the approaches to the Gulf of Aqaba, where the depth contours compress into a narrow navigable channel, and the bottom is close enough that a ship running fast at night is making a series of trust-based decisions about the accuracy of the chart data beneath it. The data is good. It is not complete. The Red Sea has been a contested waterway in multiple conflicts across multiple decades, and not all of those conflicts left complete records of what was placed in the water and where. USS Stout had been assigned to the northern Red Sea patrol sector for 18 days. The patrol required the ship to maintain a persistent presence in a corridor that had become the primary transit route for the carrier strike group's logistics and personnel movements. The line of communication that connected the operating area to the Suez Canal and the Mediterranean beyond it. Persistent presence in a narrow corridor is a tactically uncomfortable requirement. It means the ship's track is predictable. It means the surveillance assets that the IRGCN and its affiliated networks maintained in the Red Sea approaches, fishing vessels, commercial traffic, the drone relay platforms that had been cataloged over the preceding months, could observe and record the Stout's patrol pattern with sufficient fidelity to derive a track model that predicted where the ship would be on any given night within an accuracy that weapons employment required. The mine had been placed 19 days ago. Not by a warship, not by a submarine, by a small, unlit, low-profile vessel that the commercial maritime surveillance picture had logged as a fishing dhow operating in the northern approaches. One of dozens of similar vessels that transited the area on any given day, none of which had enough anomalous behavior to generate an alert in the pattern of life analysis that the intelligence team was running against the shipping traffic. The vessel had moved slowly across a section of the patrol corridor during the pre-dawn hours of a night when cloud cover had reduced satellite imagery availability to minimal, had spent 47 minutes in a position that its subsequent track behavior suggested was a laying operation, and had then resumed its prior course with no change in speed or heading that the commercial traffic monitoring system flagged as operationally significant. The mine it had placed was a contact mine of a type that Iranian naval engineers had been producing domestically since the 1980s. A spherical steel shell packed with high explosive, fitted with contact fuse horns that initiated the warhead when a hull compressed them. Not sophisticated, not smart, not remotely triggered or pressure activated or acoustic homing. A device that sat in the water at a set depth and waited for a hull to find it, with a reliability that depended on the physical contact of the fuse horns and the explosive fill's stability over time, both of which 19 days of saltwater immersion had not materially degraded. At 3:27 a.m., the Stout's hull found it. The mine detonated at 3:27:04 a.m., 4.3 meters below the keel on the port side, at a position that placed the blast beneath the forward machinery space, the space housing the forward pair of LM 2500 gas turbine generators and the associated electrical distribution equipment that provided primary power to the forward half of the ship's combat systems. The underwater detonation of a contact mine at 4.3 meters below the keel produces a different damage geometry than a warhead detonating against the hull at or above the waterline. The energy travels upward through the water column and arrives at the keel as a high-pressure wave that flexes the structural baseline of the ship. The keel, the frames, the floors, with a force that is distributed across the hull rather than concentrated at a single penetration point. The keel flexed, not catastrophically. The ship did not break in two, the frames did not fail. The hull did not rupture along its length. What the keel flex produced was a distributed set of structural responses throughout the forward section of the hull. The cracking of several weld seams along the forward keel-to-frame connections, The failure of the forward machinery space's hull penetration fittings at two locations, where the seawater cooling system pipes pass through the hull below the waterline, and the shearing of the mounts holding the forward generator pair in their structural cradles. The generators remained in their space. They were no longer attached to it in the manner their designers had intended. Seawater began entering the forward machinery space through the two failed hull penetration fittings at 3:27:06 a.m., 2 seconds after the detonation. The inflow rate through both fittings combined was not catastrophic. The fittings were designed for small diameter pipe penetrations, not for major structural failure, and the water entry through them was a flow rate rather than a flood. The initial combined rate was assessed at 140 liters per minute. Significant, not immediately fatal, manageable if addressed promptly and not complicated by anything else. At 3:27:09 a.m., 5 seconds after the mine detonation, the IRGCN helicopter arrived. It had been airborne for 41 minutes. Not a naval aviation helicopter in the Western sense. Not a dedicated combat platform launched from a warship with a crew trained to naval aviation standards. It was an Iranian military helicopter of the type the IRGCN operated in its maritime patrol role. A platform that combined surveillance with a limited weapons employment capability, and it had been operating under emissions control at low altitude on a track that had kept it in the radar shadow of the coastal terrain to the northeast until the moment its crew activated their targeting system. The Toophan anti-tank missile, an Iranian development derived from the American BGM-71 Tau system, a design that Iranian engineers had been producing domestically since the 1980s in increasing variants with improving seekers and warheads, was not a dedicated anti-ship weapon. It was a wire-guided or laser-guided missile designed for use against armored vehicles, and its shaped charge warhead was optimized for penetrating armor plate rather than naval hull steel. Against a warship's superstructure, the aluminum and steel framing, the electronic spaces, the antenna arrays, the combat systems equipment mounted on the exterior of the island. A shaped charge warhead delivered with the accuracy of a laser-guided missile achieved exactly the penetration its design specified. Whether the target was a tank's turret or a destroyer's combat system space, the physics of the shaped charge were the same. The helicopter fired 2 Toophan missiles in rapid succession at 3:27:09 a.m. from a range of approximately 1,400 meters on the Stout's starboard beam. The ship's radar had not yet processed the helicopter contact. It had appeared within the scan cycle following the mine detonation, at a moment when the watch team's attention was being pulled toward the forward flooding alarm that was activating simultaneously. The first Toophan struck the aft communications antenna array at 3:27:13 a.m., 4 seconds after the helicopter fired. The shaped charge penetrated the antenna housing and detonated inside the array structure, destroying 3 of the 4 primary communications antenna assemblies and transmitting its remaining energy into the aft electronic space that backed the array. The electronic space sustained fragmentation damage to 2 rack-mounted communications equipment units and ignited a small fire in the cable bundle that ran between the array and the space. Insulation material burning with the acrid black smoke that cable insulation fires produce in enclosed spaces. The second Toophan struck the forward mast at 3:27:15 a.m., 2 seconds after the first impact. The mast carried the primary surface search radar antenna and the secondary navigation radar. The shaped charge detonated at the mast's midsection, severing the upper portion of the mast from its base. The upper mast, with the surface search radar antenna attached, fell onto the starboard bridge wing, crashing through the bridge wing railing and landing on the deck in a tangle of steel, cable, and shattered electronics that blocked the bridge wing door and left a section of live electrical cable from the severed radar feed lying across the non-skid deck surface. The Stout lost primary surface search radar at 3:27:15 a.m., She lost 3 of 7 communication circuits at 3:27:13 a.m. when the first Toophan destroyed the aft array. She had a fire in the aft electronics space. She had a flooding casualty in the forward machinery space. She had a section of live cable on the starboard bridge wing. And she had a helicopter at 1,400 meters on the starboard beam that had just fired 2 missiles and still had ammunition aboard. The Tau had the helicopter contact on the SPY-1D at 3:27:16 a.m. 1 second after the second missile impact, 7 seconds after the mine detonation. The contact was at 1,400 meters low altitude hovering. The hover signature was inconsistent with a transit profile and consistent with a weapons platform that was assessing its strike results before deciding whether to engage again. The TAO committed the 5-inch gun to the helicopter contact at 3:27:18 a.m. The gun fired its first round at 3:27:22 a.m. The helicopter turned north before the first round reached its position. The pilot had assessed the engagement, 2 missiles fired, structural damage observed, and had made the decision that the mission had achieved its tactical objective and that remaining in the engagement envelope of a warship's 5-inch gun served no purpose that the mission required. The helicopter departed the area at maximum speed. The 5-inch gun tracked it to the limit of its effective range and fired 2 more rounds that the post-engagement analysis assessed as having missed at the engagement geometry. The helicopter was not destroyed. It withdrew. The next 70 seconds were the most demanding the Stout's damage control organization had faced in the 18 days of patrol. The damage control officer had 3 simultaneous casualties on his board: the forward machinery space flooding, the aft electronics space cable fire, and the bridge wing electrical hazard from the severed radar cable. He had 1 primary DC party and 2 secondary parties available at general quarters, and the geometry of the 3 casualties, forward, aft, and topside, placed each of them at maximum distance from the others and from DC Central. He made the allocation in 12 seconds. The primary party to the forward machinery space flooding because flooding kills ships, and the forward machinery space was adjacent to the forward generator pair that provided half the ship's electrical generation capacity. The first secondary party to the aft electronic space cable fire because fire in an electronic space with live equipment and cable insulation could cascade. The second secondary party to the bridge wing electrical hazard because live cable on a deck surface where personnel were moving was a life safety risk that could not be allowed to persist. The forward machinery space flooding team reached the space at 3:27:52 a.m., 48 seconds after the mine detonation. The space was already ankle-deep in water along the port side where the failed penetration fittings were admitting inflow. The portable submersible pump was being staged in the access passageway by the trailing team member while the lead petty officer assessed the fittings. The fittings had failed at the flange, the bolted connection between the pipe and the hull penetration sleeve, with the flange gaskets extruded outward by the shock load. Not a pipe failure. Not a hull rupture. A gasket failure on 2 flanges that had been properly torqued to specification, and that had experienced a pressure and shock load that exceeded the gasket material's elastic limit. The repair approach for a failed flange gasket in an active flooding space is specific. Isolate the system upstream of the flange. Remove the flange bolts. Replace the gasket with the emergency repair material from the DC kit. Retorque, and restore the system. The complication in this space was that the forward cooling system could not be fully isolated from the hull penetration without shutting down the cooling supply to the forward generator pair, and the forward generator pair, though its cradle mounts were sheared, was still running, still generating power, still providing the electrical capacity that the ship's systems were depending on. Shutting down its cooling would require the generator to be taken offline, which would drop the ship's electrical generation capacity by 50% at a moment when every combat system was in active use. The engineering officer made the call from the engineering control station at 3:28:14 a.m. Partial isolation. Close the cooling supply isolation valve to the maximum extent that reduced the inflow pressure without completely cutting the cooling flow. The partial closure reduced the water pressure driving the inflow at the failed flanges from the system's operating pressure to approximately 30% of operating pressure, reducing the inflow rate from 140 liters per minute to 46. The pump that was now operating in the space could manage 46 liters per minute while the gasket replacement was executed. The first gasket replacement was completed at 3:31:17 a.m. The second at 3:33:44 a.m. The partial cooling isolation was released at 3:33:51 a.m. when both flanges were confirmed sealed. The flooding in the forward machinery space was declared controlled at 3:34:02 a.m. 6 minutes and 58 seconds from detonation to flooding controlled. The aft electronics space cable fire had been addressed by the secondary party that reached the space at 3:27:44 a.m. 40 seconds after the Toophan impact. The cable bundle fire was burning in a section of cable tray that was accessible from the deck, not in a concealed overhead run, not in a below-floor chase, but in the open cable tray that ran along the port bulkhead of the space at knee height. A FFF applied directly to the burning section knocked the fire down at 3:28:19 a.m., 35 seconds after the team entered the space. The smoke in the space required the ventilation team to restore airflow before the electronics equipment could be assessed for damage, a task that required the forward ventilation control to be operated from DC Central, and that was completed at 3:29:41 a.m. The equipment damage assessment found 2 rack-mounted units destroyed and the cable bundle in the burned section requiring replacement. The communication circuits that ran through that cable bundle, one of the 3 circuits lost in the Toophan strike, could not be restored until the cable replacement was complete. The cable replacement was a 4-hour job in the aft electronics space. It was begun at 3:42 a.m. by the ship's electronics technicians working from the cable repair kit in the forward electronics locker. It was completed at 7:28 a.m., restoring one of the 3 lost communication circuits. The other 2 required the antenna array components that had been destroyed by the first Toophan, components that the ship did not carry as spares and that would require a logistics rendezvous with the supporting tender. The bridge wing electrical hazard had been addressed by the second secondary party at 3:28:01 a.m. 57 seconds after the mast impact dropped the live cable on the deck. The party's electrician identified the cable's power source, the radar feed circuit from the forward electronics space, and isolated it at the circuit breaker at 3:28:04 a.m., 3 seconds from reaching the cable to isolating its power source. The cable was then physically moved clear of the bridge wing walkway and secured to the fallen mast structure with damage control line at 3:28:31 a.m. The bridge wing was cleared as a life safety hazard at 3:28:33 a.m., 1 minute and 18 seconds after the mast fell. The surface search radar was gone. The ship was operating on the SPY-1D for surface tracking, a capability it had but one that was optimized for air surveillance and processed surface contacts as a secondary function. The SPY-1D could see large surface contacts at significant range. It could not provide the fine-grained surface picture that the surface search radar had been providing, the picture that resolved the small, fast, low-profile contacts that the IRGCN's fast boat force operated at the edge of. If a second fast boat attack developed, the Stout would be managing it with a degraded surface picture. The fleet commander was informed of the Stout's status at 3:36 a.m. The response arrived at 3:41 a.m. The nearest available vessel, USS Porter, 40 miles to the southwest, was redirected to the Stout's position. The MQ-9 Reaper drone that had been operating a surveillance track in the northern corridor was retasked to a protective orbit above the Stout's position, providing the surface picture that the destroyed surface search radar could no longer generate. The drone's optical and radar sensors established a coverage bubble around the ship at 3:49 a.m., that the Stout's CIC incorporated into its tactical picture through the drone's data link. The MH-60R helicopter that was the Stout's organic aviation asset had been on the flight deck when the mine detonated. The mine's shock load had not damaged the aircraft. The deck where it sat was forward of the blast's most severe effects, and the MH-60R had absorbed the shock through its landing gear and airframe without structural failure. The crew had their pre-flight complete by 3:39 a.m. and the aircraft was airborne at 3:41 a.m., adding its ASW and surface search capabilities to the picture around the ship. The helicopter's first significant contact was not a fast boat. At 3:52 a.m., the MH-60R's radar identified the vessel that had laid the mine 19 days earlier, or a vessel consistent with its profile, at a position 11 kilometers north of the Stout's current position, moving north at 12 knots. The contact report was transmitted to the Stout and to the fleet commander simultaneously. The fleet commander's response, authorizing engagement if hostile act or intent was confirmed, arrived at 3:55 a.m. The helicopter crew could not confirm hostile intent from a vessel that was moving north and not maneuvering aggressively. The contact was logged, tracked, and reported. It was not engaged. The investigation that would follow the night's events would determine, from the vessel's track history and its position correlation with the mine's laying date, that the probability of its involvement was high enough to warrant further action through legal channels. The legal process that the subsequent determination initiated was slower than the ship's crew would have preferred. It was the process that the law and the rules of engagement provided, and it was followed. The USS Porter arrived at the Stout's position at 4:52 a.m. and took station on the Stout's northern bearing, between the damaged destroyer and the threat axis, providing the surface search radar coverage and the weapons capacity that the Stout's damage had reduced. The Stout's engineering team conducted a full survey of the forward machinery space at first light and confirmed the structural assessment. Keel flex, weld seam cracks, generator cradle mount failures, all repairable, none immediately threatening. The generators were operational. The cooling system was restored. The flooding was contained. The ship was mobile. At 6:30 a.m., the Stout was underway at reduced speed toward the logistics rendezvous where the tender was positioned. The Porter took the patrol station. Here are the numbers when the rendezvous position is logged and the Stout's crew stands down from general quarters. 19 days the mine sat in the patrol corridor before detonation. 4.3 meters below the keel, the mine's set depth. 2 failed hull penetration fittings. Combined initial inflow rate 140 liters per minute. 2 Toophan missiles fired by the helicopter in a 6-second window. 3 communication circuits lost to the first Toophan. 1 surface search radar destroyed by the second. 6 minutes 58 seconds from mine detonation to forward machinery space flooding controlled. 35 seconds to knock down the aft electronic space cable fire. 1 minute 18 seconds to clear the bridge wing electrical hazard. 4 hours to replace the burned cable bundle. 0 fatal outcomes among the crew. 1 patrol sector held until the relief arrived. The Iranian attack had demonstrated a coordination principle that the post-engagement analysis would document carefully. The mine was not a weapon intended to sink the Stout. It was a weapon intended to stop the Stout, to disrupt her mobility and fix her position at a known location while the helicopter delivered its missiles against the systems that made her dangerous. A ship that is stopped and damaged but not flooding catastrophically is a ship whose crew is fully committed to damage control. A ship whose crew is fully committed to damage control has reduced bandwidth for tactical awareness. A ship with reduced tactical awareness and 2 destroyed antenna systems is a ship that the helicopter expected to be able to engage multiple times before the response was organized enough to drive it away. What the plan had not accounted for was the 48 seconds between the mine detonation and the flooding team's arrival in the forward machinery space. and the engineering decision at 3:28 a.m. to partially isolate rather than fully isolate the cooling system. A judgment call that kept the forward generators running while the gaskets were replaced, maintaining the ship's electrical capacity throughout the damage control sequence. Those two decisions were built from years of standing watch in machinery spaces and the particular kind of knowledge that comes from understanding a system well enough to know where its operating margins are and when they can be used. The Red Sea does not mark its mines. It does not announce its waiting. It holds them in the dark water for 19 days or 19 years or 19 decades, and it does not distinguish between the ships that knew to look and the ships that did not. The Stout had been looking. It had not been enough to find it first. It had been enough to survive finding it second.